Today in class I'll be reviewing the Chapter 2 topics that we've talked about over the past couple of weeks. Tomorrow we have our Chapter 2 test. So here are some of the basics, some of the main things that I would like our students to know as we go into the test tomorrow. Some we've covered, and there's actually one of these bullet points that I'm going to talk about right now. We kind of skipped over during the when we went through that section, but I'll cover that topic right now so they know how to do those types of problems. They kind of go along with something we did also in this chapter 2, so I think it won't be too far of a stretch to connect those two ideas, but I'll talk about it right now. In terms of what they should know for the test tomorrow, number one thing they should know is the difference between rational numbers, irrationals, integers, and whole numbers. We've talked about this a bunch of different times this chapter. We've quizzed on it a few different times too and had different types of homework assignments on it. So when they see these types of numbers, they should be able to tell me what the best name for each of those numbers is. Square root of 4, this first one, square root of 4 is just 2. And so I want them to be able to tell me that is a whole number. At least that's the best name for it. It also fits in the other categories, but whole number is the best name for that type of number. Square root of 45, I want them to be able to tell me that's going to be some kind of decimal. It's going to go on and on forever, not going to repeat a pattern, so that's an irrational number as in terms of its best name for that number. It's negative square root of 64. Well, square root of 64 is 8, so this is just negative 8 really. Negative 8 is an integer. Tomorrow on the quiz they should be able to tell me things like this for certain numbers. 550 is just a big whole number. Again, no decimal, positive number. And 9 over 2 is a fraction, so that's a rational number. So I want them to be able to, they should be able to do things like that. Tell me the best name for each of those types of numbers that we have on the board. This second bullet point here says adding and subtracting real numbers. We did stuff like this also in class. We talked about strategies for it. If I have 12 plus negative 4, then I should think of this like I have $12. Like one strategy was think of money. I have $12, and this is negative 4. It's like I owe somebody 4. So if I pay up my debt, how much will I have left? I'll have $8 left. This next problem here, we also talked about if I'm subtracting problems, what I do to still use our same strategies is I just change this into an addition problem by chopping the subtraction sign here, chop, chop. I'm going to change this into plus, and also this negative 6 into a positive 6, because I can make two changes back to back like that, and this really becomes negative 24 plus 6. And so again, it's like, I mean, I owe somebody $24, I have 6, I can't pay off all my debt, so my answer is still going to be negative. It'll be negative 18. I'll still owe them $18, so negative 18. When we were multiplying real numbers, the third bullet here, when we were multiplying real numbers, we had a little different strategies, but those we can still also talk about too. Also during this test tomorrow, which will be nice for the students, is they will be able to use their notes. So they should definitely bring those along to class, and they will be able to use those to kind of help them get the answers tomorrow, so, or at least to reference so they can look back on examples or things we've talked about in class. On a big chapter test, I usually allow that, so tomorrow they will be allowed to use their notes. So looking back at some of these multiplying real numbers problems, again, we did this in, I think it was like section 2.4. Problem like this where it's 4 times negative 6 times negative 15. Something I would hope they would be able to do is count up the number of negative signs and realize that the answer to this problem is going to be a positive answer no matter what. And then be able to multiply the numbers together. 4 times 6 is 24. And 24 times 15, I don't know that one quite in my head. I can maybe figure it out, but I'm going to use a calculator even to help me here just quickly to get the answer. So this one should be 360, and it's positive 360. Because there's two negative signs, and that makes a positive. This next one here, 3 times negative 2x times x times 5x. When they multiply these things together, they should be able to multiply all the numbers together, and also realize that there's one negative sign in the problem, so that's an odd number of negative signs, so it's going to be a negative answer. So I'm going to have negative something when I'm done. 3 times 2 gives me 6 times 5, which is 30. So it's negative 30, and then x times x times x again. The way we can write that we're going to multiply a number by itself 3 different times is x to the third power. So negative 30, x to the third. If there's one new thing that I need the students to know about for tomorrow, but it does go along with actually some things we've talked about in this section, or in this chapter, it's this section right here on dividing real numbers. We kind of skipped through that section and breezed through it during the chapter. But now this is kind of one tool they should be able to also use if they see this in a problem, something I would want them to be able to do to simplify. They should have this in their notes, or write this down in your notes if you're following along right now. Okay. Dividing real numbers, I have these three little problems up here, three little expressions. And these are problems, maybe the directions might say simplify. In these problems, like this first one says 81 minus 36x divided by 9. Remember that this big line here means divide, or in a fraction that means that you could divide the top by the bottom. Okay, I'm going to for a second jump down to this bullet point and tell you that this is kind of like distributing, whereas we're distributing, if I have some expression in parentheses and I have -3 out front here, it means take -3 times each one of these numbers individually. So -3 times 2x gives me -6x. -3 times 9 gives me 27, or -27 I should say. So I can simplify that expression by multiplying each of those numbers by -3 separately. Well, coming back up to the top here, we can actually do something very similar in this type of problem. This just has an expression, but it's divided by 9, divided by this number. And so what I can do, just like distributing, I can multiply each number individually. In this problem up here, I can divide each of these numbers individually by 9. So if I was going to simplify this expression, 81 divided by 9 just gives me 9. And -36 divided by x gives me -4. So this is actually just 9 minus 4x. I essentially just took 9 divided by this and 9 divided by this. And I can do that in mathematics. Like that does work. That means that expression divided by 9, I can just divide each one separately. Kind of like when I distribute. Kind of like that, where I multiply sometimes each number individually, I can divide by each number individually. Looking at this next one. 15x plus 25y plus 50. All divided by, all of this is divided by 5, all divided by that number. Well, that means I can actually divide each one of these numbers separately by 5. So I can divide this one, and divide this one, all by 5. 15x divided by 5 gives me 3x. 25y divided by 5 gives me 5y. And 50 divided by 5 gives me 10, so the expression now just becomes each of those things divided by 5. 3x plus 5y plus 10. This last one right here, 42 minus 70x divided by 7. Again, this line means divide. So it means take this expression right here and divide it by 7 in this case. So I can just divide each one of those things separately by 7. If I do that, 42 divided by 7 gives me 6. Negative 70x divided by 7 gives me 10, so 6 minus 10x. So again, that's something we did not cover during the chapter, but you can see it kind of relates to the distributing property in terms of I can multiply expression by each number individually. I can also divide a number by each, or divide an expression by each number individually. If I have it divided by 9 or divided by 5 or divided by 7, I can just divide each of those numbers separately, and that'll give me a simplified expression. And then the last thing I'll just mention here, the last bullet point says square roots. We did a bunch of things with square roots during this chapter also. We approximated them, and we also found the exact number for certain ones. Tomorrow there will definitely will be some that the directions will say approximate, and I'll just do this first one here. But it might say approximate this square root. So let's say this is the first problem. That says approximate the square root of 65. Again, how we talked about this during this section was we picked out perfect squares that are nearby that number, and if I know the square root of those numbers, then I should be able to figure out the square root of what, or make a guess for what the square root of 65 should be. So for example, the square root of 65, perfect squares that are close to that are 64, is just a little bit above that, or a little bit below that. The square root of 64 is 8. The next perfect square would be 81. Square root of 81 is 9. So again, I know what the square root of 64 is, that's 8. I know what the square root of 81 is, that's 9. So then the square root of 65 is between these two numbers. So it must be between also 8 and 9. So it has to be 8 point something. And again, in class we talked about making approximations for this. Since it's a lot closer to 64, I'm going to guess something on the lower end of 8 point, something with a decimal. So I'm going to say something like 8.1. Okay. But again, that's how we talked about approximating square roots. You can also find the exact square roots for certain numbers. If I look at square root of 81 right here, square root of 81, we actually just did that one, but square root of 81 is just 9, and then this just says make a negative. So some numbers will say find the square root, some will say approximate. The directions will say that on each particular problem what you want to do. But just kind of last bullet point here is we worked on square roots, so something else they should know how to do too tomorrow. So again, all these different topics, some of the main ones that we worked on during this chapter, things they will need to be expected to know for the test tomorrow.